Hi students, today we are going to see about matter in our surroundings. So this topic has lot of connections in our life, okay. So we are going to see what do you mean by matter, okay. So what do you mean by matter? Matter is the substance, okay, which occupies space and has mass, okay. Anything which occupies space, for example, I am going to take this pen and keep it on the table, and definitely this particular pen have this much space, am I right? So this much space is there. So now when I keep it on the table, it occupies some space, am I right? So that's called matter. So anything which occupies space and has mass is called matter, okay. It can be book, it can be scale, it can be anything, notebook, pen, chair, anything, okay, which occupies space and has mass is nothing but matter. So come on, let us go to the video and see the classification of matter, alright. So matter is a substance which occupies space and has mass, okay. Now the matter is classified into pure substance, and the mixture. So what do you mean by pure substance and what do you mean by mixture? Pure substance is nothing but it could be an element, it could be a compound. So what is the, let us see what is the basic difference between element and the compound. Element is the substance which is made up of only one kind of atoms. Element is a substance which is made up of only one type of atoms. And what about the compound? Compound is made up of more than one type of atom but in the fixed proportion, okay. For example, what is the formula for water? H2O or H3O? It is H2O. Yes, you are right. So H2O, okay. H2O is the formula. It consists of 2 atoms of hydrogen and 1 atom of oxygen, alright. So pure substance is classified into element and compound. Element is the substance which is made up of only one kind of atoms, only one type of atoms, okay. Example for element, say sodium. Sodium, what is the symbol? Na. So sodium atoms means it is made up of only sodium atoms. If you take a lattice of sodium, it will be made up of only sodium atoms, right? Then copper. So copper is a metal, and obviously between the copper atoms, what will be there? The attractive force will be there, and it will be made up of only copper atoms, alright. S8. So I have written S8. What is the meaning of that? Sulfur consists of 8 atoms. So I can say it is octa-atomic. So it consists of 8 atoms. So sulfur is made up of 8 atoms. P4. How to represent the phosphorus? P4. What is the meaning of that? Phosphorus is made up of 4 atoms. So generally we say it as P4. O2. Oxygen. Oxygen is diatomic. In sense, it is made up of 2 atoms of oxygen. One molecule of oxygen is made up of 2 atoms of oxygen. But what you observe here, if it is sodium, it is made up of only sodium. If it is copper, it is made up of only copper. If it is made up of phosphorus, it is only made up of phosphorus. It doesn't have any other thing, right? So then it is called element. I hope you understood what is element. So element is the substance which is made up of only one type of atoms. Then it's called element. Okay. So now we are going to see compound. So what is compound? Compound is the substance which is made up of more than one type of atoms. It is made up of more than one type of atoms, alright. And but what is the condition? But it is going to be in a fixed proportion, not randomly. Okay, it's a fixed proportion. For example, water. The formula for water is H2O, which means one molecule of water consists of 2 hydrogen atoms and 1 oxygen atoms. Alright. CO2, carbon dioxide. So what is carbon dioxide made up of? 1 carbon atom with 2 oxygen atom. So CO2. H2SO4 means sulfuric acid. What is H2SO4 meaning? Meaning in sense it's an acid. Okay. And what is the formula? H2SO4. So one molecule of H2SO4 consists of how many atoms of hydrogen? It's 2. How many atoms of sulfur? 1. How many atoms of oxygen? 4. Right? So, but it's you can see that it is fixed proportion, not randomly mixing. Alright? So, that's called compound. Okay? So, once again I'll repeat, matter is the substance which occupies space and has mass, is nothing but matter. Matter is made up of 2 types. Okay? One is pure substance, the other one is mixture. So, what is pure substance? Which is made up of only one kind of atoms or in a fixed proportion. So, we can say that as like pure substance is classified into 2. One is element, another one is compound. An element is the substance which is made up of only one type of atoms. Example, sodium, copper, sulfur, phosphorus, oxygen. And similarly, what is compound? Compound is made up of more than one type of atoms but in a fixed proportion. So, water H2O, carbon dioxide CO2 and H2SO4, which is nothing but sulfuric acid. Right? Now, let us go to mixture. So, what is mixture? And you would have come across we take mixture, no, we eat. Now, what is a mixture? Randomly having different stuffs in that. Okay? The mixed nuts is there, right? So, it consists of badam or cashew nuts. Okay? It will be mixture, right? Different types of nuts will be mixed there. So, mixed nuts, right? Same way, what is mixture? Randomly mixing substance is nothing but mixture. Alright? So, here any fixed ratio? Not at all. Randomly mixing. So, it's called mixture, right? So, the mixture is classified into 2 types. One is homogeneous, another one is heterogeneous. Okay? So, now let us see. Mixture is classified into homogeneous. Another one, heterogeneous. Homogeneous, heterogeneous. So, what is the meaning of homo? Means same. What is hetero? Means different. Okay. So, what is homogeneous mixture? When randomly mixing the stuffs which they mix thoroughly. Okay. So, I can tell you that uniform concentration. Okay. Everywhere it is uniform, everywhere it is same. Okay. Uniformly distributed. When the atoms are uniformly distributed, then it's called homogeneous. Very good example I can give you is air. Air is a mixture, right? In our atmosphere, there are so many gases present. You know, it consists of oxygen, nitrogen, hydrogen, carbon dioxide, right? Nitrogen dioxide, etc. All these gases definitely is going to be there in our atmosphere. Can you see any identification by seeing? Can you tell me? Like this is oxygen, this is carbon dioxide? No, we can't say no, right? Can you see the air? Can you see the air? No, we can't see the air, right? But we can feel it, right? In a breeze, when you get the breeze, you know that, so there is a breeze here, there is a, air coming, air flow is there. That's all we can say. But we can't say oxygen is here, carbon dioxide is here. Definitely we can't say. Am I right? So, air is the mixture, okay? What mixture? Homogeneous mixture. So, thoroughly they mix. Okay? This is one example. Another example I can tell you. Say 1 glass of water is there. I am going to take 1 spoon of sugar and I am going to mix it thoroughly. So, can you see the sugar particles after mixing? No, right? It will be thoroughly mixed. You can't see anything, right? So, you can see just water, that's all, right? Which means that the sugar molecules thoroughly it gets dissolved in water. Am I right? So therefore we can't see. So it's uniform concentration or uniformly distributed. So you can't see that, right? So it's a homogeneous mixture. It's an example for homogeneous mixture. So sugar in water. Similarly, salt dissolved in water. So when you take salt and dissolve in water, can you see the particles, salt particles? No, you can't see. Okay. So thoroughly it mixes. So it's an homogeneous mixture. So understood what is mixture? Yes. So mixture is randomly mixing stuffs. Okay. Randomly mixing the substance. It's of two types. One is homogeneous, another one is heterogeneous. So what is homogeneous? Homogeneous mixture is nothing but which is uniformly distributed. The atoms are being uniformly distributed. For example, when I mix sugar in water, the sugar particles will get distributed between the water molecules. The space between the water molecules will be there, no? There this sugar will go and get occupied. So thoroughly it mixes. Fine. So we can't see. So air is a mixture, right? So I'll write the example here. Air. Okay. Sugar in water. Salt in water. Salt means I mean NaCl, sodium chloride. Now what about the heterogeneous mixture? What is heterogeneous mixture? Hetero means different. Am I right? So here we can see the difference. For example, when you take a glass of water and add like 1 spoon of oil. So do you think the oil mix with water? Yes? Is that so? Will it happen? No, it won't mix. Okay. So oil is having a different, it is made up of different substance, and water is made up of H2O, you know. Both are different. So they don't mix at all. So it is heterogeneous. Sand in water, next example. Or stone in water. If you put stone in water, what will happen? Will the stone will mix? Will the stone will get dissolved? No, right? So it will go and settle down. So you can see the difference, right? Yes? You can see this is, here is the stone and here is the water. Definitely you can say that. So they don't mix at all. So heterogeneous mixture, which means that they don't mix at all. Okay, wow. They don't, combine. They don't mix. So example, oil in water. Oil in water. Then sand in water. Correct? Or stone in water. Definitely they are not going to dissolve. And you can see the difference. Right? Understood? So pure substance, and what is pure substance and what is mixture. So mixture is of two types, homogeneous, heterogeneous. Homogeneous where the particles get uniformly distributed, whereas in heterogeneous they don't get uniformly distributed. Okay. And example for homogeneous mixture, air, sugar in water or salt in water, and heterogeneous mixture, oil in water, sand in water. Calcium carbonate also we can say, chalk piece powder is there, no? Calcium carbonate it is. So when you put it in water, no, it will go and get dissolved. I mean, it won't get dissolved, it will settle down. Suspension, we can say. It will go and suspend. It will go down, which means because of the density difference. So you can't, see them getting dissolved. Fine. So it will go and settle down. So these are the homogeneous and heterogeneous mixture, and pure substance is the element and the compound. Hope you guys understood, right? So now I am going to give you the difference between compound and the mixture, right? So now let us go to the next slide. Compound, mixture. So compound, what is the difference between compound and the mixture? So when you take the different elements, when they combine in the fixed ratio, it's called compound. Am I right? When two or more elements combine together in a fixed proportion, it's called compound. Am I right? In a fixed ratio. So the elements combine in a fixed ratio. Here, not in a fixed ratio, right? Randomly mixing. Okay. Example, when iron combine with sulfur, okay, it forms FeS. Okay. Now here, same example I will take. Iron powder and sulfur powder is allowed to mix. Okay, right? So here in a compound, Fe, that is iron, combines with sulfur and it forms FeS. Okay, and here also I am just taking one spatula, one spoon of iron powder and one spatula of sulfur powder, and I am mixing them, right. Now in a compound, what happens when you mix and heat it? I am going to heat it. So when I heat only, it forms a compound ferrous sulfide. Okay. Now I am going to tell you one important thing. What it is? What is the shortcut here? Compound is made up of more than one type of atoms, but in a fixed ratio. Am I right? The very important thing here is elements loses its identity once when it forms the compound. Example, let us test it. Now you got ferrous sulfide, one compound, right? FeS. Now I take magnet near to it. Generally what the magnet will do, it will attract the ion. Am I right? Once when it forms ferrous sulfide, and now you are taking the magnet near to it. So now whether it will get attracted? Not at all. It won't get attracted because elements loses its identity once it forms the compound. Fine. Now come to the mixture. Now I took one spatula of iron powder, one spatula of sulfur powder, and I mixed. Now I am going to take the magnet near to it. Now what will happen? All the iron fillings will get attracted to the magnet. Okay, wow. So now you can separate the sulfur powder. There only sulfur powder color is yellow, and iron fillings, everything will get attracted towards the magnet. You can separate them. Okay. So in a mixture, elements will retain its identity. It retain its properties. That's why when you bring the magnet near to iron fillings and sulfur powder, iron fillings means what? Powder. The iron powder will get attracted, not the sulfur. Whereas in FeS, once when it forms the compound, when I take the magnet near to it, no attraction takes place. Got it? Hope you understood. So in a compound, elements loses its identity. What about the mixture? It will retain its properties. Elements will retain its properties. So in a compound, elements cannot be separated by physical means with the help of the magnet. Can you separate? No. Whereas in a mixture, you can separate the elements by physical means. Physical means you use magnet or you hand picking, something like that. Okay. Here we use magnet to remove the iron fillings from the sulfur powder. Got it? So this is the very important difference between compound and the mixture. So once again, compound is nothing but elements, two or more elements combine in a fixed ratio, whereas in a mixture, elements they don't mix in a fixed ratio. And how to form a compound? When I take iron fillings and sulfur powder, mix it and heat it, it forms a compound called ferrous sulfide. Okay. Whereas they are randomly mixing. In the mixture, you randomly mix one spatula of iron powder and one spatula of sulfur powder. Now I take the magnet near to it, iron fillings will get attracted, whereas in the compound, iron will not get attracted. Fine. So what you understand from this experiment? In a compound, elements which loses its identity, whereas in a mixture, it retain its properties. Okay. Hope you guys understood this video about the simple concept called matter and the difference between compound and the mixture. Let us see in the future videos, right? Thank you, students.